In this lecture, I want to demonstrate some more features of C syntax. In particular, reading and writing files, using command line arguments, and operating on strings and characters. To get into all of that, let's write a rather silly example program. I'm going to write a program called shout.c, whose purpose is to read in a text file and then produce a new text file where everything in the first file gets shouted. And what I mean by shouting is that all of the text will be capitalized and it will be a big block of text where lines wrap at a fixed number of characters. So we'll start with a top-level comment at the beginning of our program describing what the program does. And in C, we can do block comments starting with /* and ending with */. Now we can start with the default structure we use for all of our C programs, where we'll always want to include the standard I/O library. And we'll declare a main function. And now we can get to programming. We'd like for our program to take as command line arguments the name of the input and output files. In C, the way the program receives command line arguments is as inputs to main. In our previous examples, the main function has taken no arguments, but we can also write C programs where the main function takes two specific arguments. First, an integer called argc, which is the number of arguments that were given on the command line. And second, a char star array called argv, which is an array containing the actual command line arguments. Argv is an array of strings, but in C, strings are represented as arrays of characters. And so the type of things in the array are char star. So char star means pointer to character, and we will talk more soon about the connection between pointers and arrays. But for now, we can think of this as an array of characters representing one string, and then argv is an array of strings. And so the first argument to main tells us how many strings there are in the array argv. And so a good practice, if we are expecting command line arguments, is that one of the first things our program should do is check that we got the right number of arguments. So here we are printing an error message to the user and then returning from main, which causes our program to exit. In C, the main function returns an integer, and the convention is that it returns 0 if everything went fine, and it returns some non-zero value if there was some kind of error. So to make that clear, we could, at the end of our main function, return 0 if everything went okay. So the case where we want to print this error and exit is when we weren't given both an input file name and an output file name as command line arguments. But the array of command line arguments always has one more element, which is the name of the program that was run. So in argv, if we were given two file names, an input file and then an output file, we would have argc equal to 3, because the first element would be a string, which is the name of the program, then the second string would be the input file name, and the third string would be the output file name. So we want to print an error message if the number of arguments is not 3. If the user gave us 3 arguments, then we want to treat element 1 of this argv array as the name of the input file that the user wanted us to read. So to read that file, we need a file pointer variable. So the type of variable here is file star, and it is using file star variables that we do input and output in C. We can think of this variable as starting off pointing to the beginning of the text in the file, and then as we read from the file, the pointer into the file will move along and point to the next thing that we are going to read from the file. And we are assigning into this file pointer variable the result of opening the file specified by argv of 1, and we are opening it in read mode. But it's possible that the user might have given us an invalid file name, and if that's the case, we want to catch it here rather than proceeding, so we should check after opening the file that we were successful. In the case that opening the file failed, the fopen function will return null. Null is a special pointer value that is never valid, and so checking for an invalid file pointer tells us whether we succeeded in opening the file. And again, we'll print an error message and return from main. We should also open the output file and check that that operation succeeded, but for the output file, we'll want to open it in writing mode. So if we've made it to this point in the program, we know that there were 2 command line arguments beyond the name of the program, and that we succeeded in opening the first of those command line arguments as a file that we could read, and opening the second one as a file for writing. So now we can use C's functions for reading and writing files to read from the input file and write to the output file. But before we do that, we should probably pause to test that our program is actually compiling and running in the way that we expect. We could make a new terminal inside of VS Code, but since I have a terminal open right here to the folder that I'm working in, I'll use that. Compilation successful, and I'll run a.out, and argc was not equal to 3, so we triggered our first of the error messages. That's a good result. If I run a.out and give it a couple of command line arguments, then we get past the first check, and when trying to open a file named 1, well, there was no such file in the current directory, and so trying to open that file for reading failed, and we were unable to open the input file. I do have in this directory the text of a Sherlock Holmes story, and so we can give that as the input file, and we'll make up a file name for the output, and that appears to have worked. If we do another ls, we now have a file called out.txt, and out.txt is an empty file because we opened it, but we didn't write anything to it. Once we do start writing to the file, we'll want to make sure that that actually saves at the end of the program, and so we should make sure to close both the input and output files before we return from main. We can do that in C with the fclose function, passing in the name of the file pointer, and so we'll close both files at the end. So now we'd like to actually read the input file and convert the letters to uppercase and wrap the lines. There are a number of ways that we could implement this. Some functions that would come in handy are the fgetC function, which reads from a file 1 character at a time. But there's also the fgetS function, which reads an entire string from a file. The fgetS function takes 3 arguments. The first is a location where it can put the string that it read. The second is the number of characters that should be read into that location. And then the third is the name of the file. And the fgetS function has the handy feature for what we are trying to do, that it will read until the first of reading the specified number of characters, or reading until the end of a line. So we can ask fgetS to read up to 80 characters, and if it reads 80 characters, then we know we need to wrap the line, and if it read less than 80 characters, then the thing that it read will be the end of a line from the original text. So the third argument to fgetS should be the file we want to read from, which is infile. And for the first argument, we want a place to put the string that was read. Well, strings in C are represented as arrays of characters, so let's make an array of characters. And the size of that array should be big enough to read all of the characters that we are requesting from the file. Since we're allowing our lines to be up to 80 characters, we want to make the size of our line be 81. The reason for this is that every string in C ends with a special character indicating the end of the string. And so if we have 80 actual characters in our string, then we will need 81 elements in our array so that the 81st can be that end of string character. So then we tell fgetS in the second argument that the size of the space it can write to is 81, and we give it as the first argument the location that it can write the string to, which is the array line. Now, having this magic number 81 in the middle of our program seems rather fragile. If we were to have 81s appearing all over the place and change some of them but forget to change others, that could be a major source of bugs. So a good practice when we have an important constant like this is to define it at the start of our program. We can do that with the #define directive in C, and so then we give a name to our definition. We'll call it line length, and then we give it a value. And the maximum line length is 80, and so then we can use line length plus 1 as the size of our array. So the fgetS function will read initially from the beginning of the file, but then as we call it more times, it will each time continue reading from the point where it left off last time. Eventually, though, if we do this over and over again, we will get to the end of the file, and fgetS will return null if we have reached the end of the file and there's nothing left to read. So let's put this in a while loop. And the condition of our while loop can be that we keep calling fgetS as long as it doesn't return null. If it ever returns null, that means that there was nothing left to read, and so it wouldn't make sense to execute the body of our while loop or continue reading. And then inside this loop, we can do the manipulations that we want to on the string, like capitalizing all of the lowercase letters. Before we get to that, though, let's actually check that we can write the lines to the output file. So we've called fgetS and read into the line variable. We can use the fputS function to write a string, that is a character array, into a file for writing, like the out file. So now, if we save, compile, and run, if we take a look at our out.txt file, we haven't succeeded in shortening the lines. This first line of the file is over 1,000 characters long. So the trouble was we read things only 80 characters at a time, but we want to make sure that when we are writing it to the output file, we put a new line after each of those strings that we read so that they are separated onto different lines. So let's also put s, a new line character, to the out file on each iteration of the loop. And now if we compile and run, our lines are wrapping after 80 characters. So now we'd like to make sure that the text gets shouted, and so we would like to have a function that capitalizes all of the characters. So we can loop through this line, and calls a function to capitalize the ith character in the line. And then we should put that back into the position that we got it from. So we now need to write a capitalize function that will turn all of the lowercase letters into uppercase letters. And if the character was not a lowercase letter, then we want to make sure that we preserve whatever it was so that we can put it back. And also, since sometimes the line that we read will not take up the entire array, it will have a length shorter than 80 characters, we want to make sure that we don't mess up the end of string character that indicates where that string stops. So let's write ourselves a capitalize function. So this takes as input elements of our array of characters, and then we put the result back into that array of characters. So the return type of our function should be a character, and the input type should also be a character. And so now we want to change a lowercase letter to be an uppercase letter. To do that, we can take advantage of the fact that characters in C are actually integers under the hood. A character is an 8-bit integer type, and so we can compare different characters with less than and greater than. We could look up the ASCII codes for all of the lowercase and uppercase letters, but if we know the fact that all of the lowercase letters are consecutive in ASCII and all of the uppercase letters are consecutive in ASCII, then we can detect a lowercase letter by just checking whether the integer representation is between the representation for A and for Z. So we'll check that the letter's numerical representation is greater than or equal to the character A, and double ampersand means logical and, that the letter's character representation is less than or equal to the character lowercase z. If that's the case, then we want to return the character representation of the corresponding uppercase letter, and we can do arithmetic on these character integer types. So we could add to the letter an amount that is the difference between the representations of lowercase a and uppercase a. This difference will evaluate to how far apart lowercase a and uppercase a are in ASCII characters, and since all of the lowercase letters are consecutive and all of the uppercase letters are consecutive, we can add that offset to lowercase q to get an uppercase q. So we can return that value, and if the character wasn't a lowercase letter, then we can just return what was passed in. So now let's try again. Compile and run. And now our output is the shouted version of our Sherlock Holmes story. So to summarize, in C, command line arguments are passed into main. The number of arguments is the argc input, and the array of the command line argument strings is called argv. And the first thing is always the name of the program. So if we want 2 command line arguments, we make sure that there are 3 elements in argv. To operate on files in C, we use file star variables, and we can use fopen and fclose to open and close the files. We can specify whether we are reading or writing when we open the file. And we can use fgetS and fputS to read and write strings from and to files. And there are similar functions like fgetC, fputC for reading and writing individual characters or other types of data. Be sure to read through the assigned sections of Dive into Systems, which covers file I/O and strings and arguments in C in greater detail.